Hi, hello and welcome to the final video in this series where we build a complete ChatGPT iOS application. And in this one, we're going to wrap everything up and connect OpenAI's APIs to our app and also connect to Firebase to be able to store our messages and our chats. So let's get straight into it and jump over to our chat list view model. We're going to start everything in our chat list because that's the first interaction point where we create our chat. So we're going to jump over to our create chat function and add a parameter to pass in our user. So this will be a type string and it's going to be optional. It's asynchronous, it throws, and we're going to return a string which will be the document ID for our chat. We'll make sure we bring in our database. So private let db equal to Firestore. Make sure we've imported Firestore. So Firestore dot Firestore. Say let document equal to db.collection, and this collection is going to be chats. We'll say add document and pass in the data for this document. Now the only two things that we want to pass to create our chat is when the last message was sent, which is pretty much the creation date of our chat, and also the owner of the chat, and that'll be yourself. So this is where we'll say last message sent, and it's going to be, we'll make sure that this is a string, and we'll pass in the current date. And then we'll also add an owner property. And the owner is going to be user. Otherwise, we'll just pass in an empty string. And then we're going to return document.document ID. We also want to create the functionality for us to be able to retrieve our chats. And this is going to replace the content we have here. I'm going to leave this for now and just write underneath it. And then I'll delete this once. We'll first check if our loading state is equal to none. And in that case, we're going to say loading state equal to loading, and we'll say db.collection chats. And we also want to now make a query where we filter our chats where our owner is equal to our user, and otherwise we'll pass in an empty string. That also means we need to pass in the user parameter into our fetch data, and that'll be of type string, again, also optional. And then we're going to add a snapshot listener. So we'll constantly be listening for any new chats that get created. And that way we'll also be able to update our chats list when the message is created without having to do it ourselves. So we'll say add snapshot listener, and this is query snapshot, and also the error. Make sure we keep a weak reference to self so we can avoid any memory leaks. And we'll say guard let self equal to self, else we'll just return from here. We're also going to check if our query snapshot has any documents. We'll go guard let self equal to self, and we're also going to check that our snapshot has any documents, and we'll say let documents equal to query snapshot dot documents, else we'll change our loading state to be equal to no results found, and then we'll return from here. Now, if we do find our documents, we then want to convert those into our app chat and then store those in the chats array. The way we're going to do that is by saying self.chats is equal to documents.compactMap, and we use a compact map so we can leave out any of the nil values. We'll say compactMap snapshot, which returns an app chat. And in here, we want to convert the snapshot into our app chat. So let's head up here and import Firestore Swift. And then we can say here, return an optional try snapshot.data as, and we can say appchat.self. We then also want to sort our messages so that the most recent one is up top. So we'll say sort last message sent is greater than the last message sent. And in our create chat, we also need to make sure that we add our try and our await, because it is asynchronous and it can throw an error. Now, a lot of issues that you'll find when working with Swift and Firebase has to do with the way dates are encoded when you store or retrieve them. I've also put together some functionality that helps us work with that, and I'm going to show you how I do that. The thing is, the way Firebase stores dates is as a timestamp string, and so when you bring that in, it's a bit difficult to convert it directly into a date object, especially if you want to use Firebase's built-in functionality. So I'm going to create a Firestore date, And then we'll use that instead of our normal date object whenever we're working with Firebase models. So we're going to say struct Firestore date. We want our date to be codable, hashable, and also comparable, because we want to be able to compare two separate dates. Our Firestore date is going to have a date property, and we'll also have an initializer that initializes to the current date if we don't pass anything in. So init date, and this is just going to say self.date equal to date. We then want to create our decoder initializer. We're then going to create a container by saying let container equal to try decoder dot single value container. We'll also say let timestamp equal to try container dot decode timestamp dot self, and then we can say date equal to timestamp dot date value. And then we also want to add our encoder function. So we'll say encoder, encode2. We're also going to create a container here, but we can just say let container equal to encoder dot single value container. We'll then say let timestamp equal to timestamp and pass in our date. Then we can say try container dot encode and pass in our timestamp, and that should encode our timestamp. And because this actually mutates the container, I'm going to change this to a var. And the final thing I want to add is the comparable functionality. I can just bring in that protocol stub, and I'll say LHS dot date is less than RHS dot date. Grab that, throw it down the bottom. And now we have our Firestore date that we can now use in our models. I'm going to go up to our app chat and change the last message sent from date to Firestore date. I'm also going to annotate our ID with document ID. And what this does is whenever I retrieve an object from Firestore, it'll actually get the document ID and place that in place of the ID here. And to do that, I need to change this to a var instead of a let. We're going to jump over to our chat view model and do the same thing. We'll import Firestore Swift. We'll annotate this with document ID and also change this to be a var instead of a constant. We'll also change created at to also be a Firestore date. Now the errors we're getting here are pretty simple. They're just wherever we've already created a date instead of a Firestore date. So I'm going to go ahead and comment this out. I'm also then going to comment this out in our chat list view model. I'll make sure that the ID in our app chat isn't optional and Firestore date. Within our app chat struct, our last message time ago was using the date object. So we just need to say last message sent dot date, and that should fix the error for this function here. And to be able to get rid of this whenever we create a new message, we can actually remove the created at from here and just add a default value like this. And let's jump over to our chat list view model, go to our Firestore date, and make sure this has a default value. So we don't always have to initialize it. It'll just initialize with the current date. Now, if you recall, we changed the fetch data and the create chat functions to take in the user. We can actually get our current user from our app state. So if we go to the top of our chat list view, we can then say at environment object var app state, and that's going to be of type app state. And then I can go down to my fetch data function and say user, and then pass in app state dot current user dot UID. And then also the same thing for create chat. I'll pass in the user there, and I'll say app state dot current user dot UID. And because the create chat functionality is asynchronous, we'll wrap this in a task. So we'll say task do catch. We'll grab this and we'll say try await view model dot create chat. And of course, if we do get any errors, we're just going to print those out in our catch here. So we'll say print error, but hopefully we shouldn't have any. This function here is going to return back our document ID. So we'll assign that to chat ID. And then to navigate to that view, we're going to say app state dot navigation path dot append and pass in the chat ID. And this is going to trigger the navigation path to jump onto our stack, and then we can navigate to our chat. So now at this point, if we run through the flow, we have our chat list view, And down here in our toolbar, we have the create chat function. So when we go to create our chat, we're going to say viewModel.createChat, and we'll grab the chat ID once it's been created. And then we'll be able to add that and append it to our chat here. So we're going to build and run and see what happens when this loads. So we still have the loading chats and nothing's changing there. So let's go back to our chat view model, so chat list view model, sorry. In our fetching data, we should actually, by the end of this, then say self.loading_state is equal to results found. When you run that, you'll notice that it actually does have the results found state. And the reason for that is because we didn't actually check if our documents are empty. So let's just make sure documents.is empty. I want to make sure that it's not empty. Now, if we run this, then we should have our no results found state. There we go, no chats. If I go to the top, I click this, it created a new chat and navigated me over to the next view. I can toggle between the two models, and I can also send a message, but nothing happens at this point. There is a big gap up here, and that's because it's using the large title display. I'm going to go ahead and say navigation title display mode and make that inline. And that's also going to have where we add our chat title. We're going to say navigation title, and this is going to be equal to our view model dot chat dot topic. Otherwise, it's just going to say new chat. Let's build and run that. And then if we click into this chat, we have new chat up the top. Now, this is one of the more complicated parts of the application, and that's where we're going to send the message. Now, when we send the message, what we want to do is store the user's message in Firebase, then send that message over to OpenAI for it to generate a response. When we get that response, the response is going to come back. We create a new message, we store that in Firebase, and then also display that to the user. So let's run through that flow and build that out. Let's head over to our chat view model. Let's make sure we have the standard Firestore imported as well. Once we've imported Firestore, let's create a reference to our database. So let db equal to firestore.firestore. We're then going to create a function below our send message to be able to store our messages in Firestore. So we'll say private func store message, pass in our app message. It's going to be a throwing function, and this will return a document reference. We're going to return try db.collection chats.document, and this is going to be the chat ID, and this is going to be the chat ID. We'll then access the sub collection of messages within that chat, and we'll add document from our message. It's as simple as that to store a message in Firestore. So now we'll jump back up here. We'll make this a variable instead of a constant. And before we append to the messages or clear the text field, we're then going to say do catch, and inside this, we'll say let document ref equal to try store message, and we'll pass in our new message. Once our message comes back, we're going to update the new message ID with the document reference ID. If there was an error, we'll just print out that error down here. Now, if you recall at the beginning of this series, I mentioned the way that we're going to manage which model is being used for a chat is when the user sends their first message. So when they send their first message, whichever model is selected at that point in time, we're going to save that as the chat model. So what we want to do is check if the messages in this chat are empty. If messages.is empty, we're going to set up new chat and create a function just down below for that. Private func setup new chat. If it's not empty, what we want to do in here is update the Firestore reference to the model. So we'll say db.collection, again, chats.document, add our chat ID, and we're going to say update fields. And the field we want to update is model, and let's update that with selected model.raw value. Once we've done that, we can then say dispatch queue, because we want to make sure this is running on the main thread, main.async, and we're going to say chat.model equal to selected model. It's telling me that the chat model property is a constant. So let's just go over and make sure that our model is a constant. So let's just go back and make sure that our model property is not a constant, and we'll change that to var. Go back to our chat model and we're good to go. We'll keep a weak self reference, and we'll say self.chat is equal to self.selected model. and all the errors are gone now. Then we'll make sure that these UI updates are done on a main thread. So let's say await main actor dot run, and I'll grab these and pop that in here. We'll make sure we capture the new message so we can use it in this function, and then also annotate this with async. Now below this is where we're going to actually send the message through to OpenAI to be able to generate our response. Let's create a function below that says func generate response, and we want to pass in the message, which is app message, and this is just going to be an async throwing function. So let's start writing the code for how we're going to generate the response. Let's create an instance of OpenAI. So we'll say OpenAI and pass in the API token. I'll show you how we'll get the API token from the profile view in just a moment. So we'll create the OpenAI instance, and then we'll say let query messages equal to messages.map, and this is an app message. We're going to then create a chat with role equal to app message dot role, and the content is going to be app message dot text. We then create our query, and that'll be from our model and our messages. So we'll then pass in our chat model and our query messages. Now the reason we're getting an error here is because our chat model is not the same model that this is expecting. So what I'm going to do is head over to our chat model. So go to chat model, and in here I'm going to add a model property. I'll need to import OpenAI here, and I'll go back down to the chat model, and this is going to be of type model. I'm just going to switch on self. In this case, I'm going to return .gpt 3.5 turbo, and in this case, I'll return GPT-4. Now, if we go back, we can say model.model, and that'll get the model that our chat query is expecting. Now, we need to unwrap this in case it doesn't exist. And in our case, we're just going to pass in GPT 3.5 turbo as the default. When we send this message through to OpenAI, we want to stream back the responses so that we get them as the response is coming back rather than all at once and having to wait a really unreasonable amount of time. So what we need to do for that is say for try await result in OpenAI.chatStream and pass in our query. We can say guard let new text is equal to result.choices.first.delta.content, and if that doesn't exist, we'll just continue from this function. And the reason we've called it new text is because a new set of text is going to be coming through at each point. Now, if this is the first response we get back for the message that we've sent, we're going to store that as a new message. If we've already got previous responses, we're going to pull the old message and just append the new message to that and save that back. So let's await main actor.run so we can make sure that these UI changes are happening on the main thread. We'll check if the previous message was the user, and that means that the current message is a new message. So if let last message equal to messages.last, and then last message.role is not equal to user, which means we already have messages come back from this same assistant before. So if we have a previous message from this request, we're going to say messages dot count -1 dot text plus equal to new text. If this is the first time we receive a message, we're going to say let new message equal to app message and pass in the ID. The ID is going to be our result.id. The text is going to be new text, and the role will be assistant because the message is coming back from the assistant. Then we'll say messages.append new message. Once the messages have completed, we're then going to store that message. So if let last message equal to messages.last, I'm going to say try store message and pass in the last message. And this is going to store the message in Firestore. And then I'm going to jump back to our send message function. I'll make this a throwing function. And then I'll say try await generate response for our new message. And that should then generate a new message for us. Now, because everything that's happening is asynchronous, we need to make sure that the calls made from our UI are also asynchronous and running in a task. So let's go into our chat view, and so that we don't have to write this multiple times, let's just extract this into a send message function here. So send message, and I'll say task, do, catch, and I'll say try await view model dot send message. And instead of this here, I'll just say send message, and I'll also do the same thing here. So send message. In here, we'll print out the error, and we'll see that our build has succeeded. If I jump into this, I'll say hello, send a message. We'll see that nothing comes back because we don't actually have an API key. Now, for us to get the API key, we're going to go into our profile view. In here, we're just going to say list. It's super simple. In this one, we're going to create a section with a title, OpenAI API key, and the content for this is going to be a text field, enter key, and it's going to be binding to a state variable called API key, which will be of type string, and the default value will be equal to user defaults dot standard dot string for key OpenAI API key, and default to an empty string. I'm going to bind the text to our API key, and then also add an on commit so that when we press enter on this, we can also store the value. So we'll say user defaults dot standard dot set, and we'll pass in API key, for key OpenAI API key. Now, if we pop open that view, we can see that it lets us add in our OpenAI API key. And I'll just throw in an API key in here, hit enter, and let that store. If I build and run again, and open up the preferences view, you'll see that the API key is still there, which is really good, and that means we can use it in our application. In our chat view model, to be able to use that API key, we're going to use app storage. So we'll say app storage, pass in the key, which is OpenAI API key, and store that to API key. We're going to default to an empty string and go back down to where we created our OpenAI instance and then pass in the API key. To use app storage, we want to import SwiftUI, and that should be good for us to go there. Let's try build and run and see how that goes. And then we're going to jump into our chat and test the message. So we'll say hello, wait for that, and there we go. We can see that we're actually getting our messages coming back. So test this out, and we get another message coming through. Now, when we jump into the chat, we can see that the chat is actually empty, and that's because we haven't added the fetch functionality for our chat view. So let's head over to our chat view model and jump into the fetch data function. And here we're going to fetch the chat and the chat messages. So we're going to say db.collection chats.document, and the document here is going to be chat id.getDocument as, and it's going to be an app chat.self. We'll get back a result, and we're just going to switch on that result and say switch result dispatch queue.main.async, and then we'll store our self.chat is equal to the success. Else, if there's a failure, we're just going to print out the failure. Then to grab our messages, we'll say db.collection chats.document, pass in the chat id, .subcollection messages.getDocuments, and then keep track of our query snapshot and our errors. We'll check that the document actually has any messages. So guard let documents equal to query snapshot.documents, and documents dot is empty is false, else we're going to return from here. Then we're going to assign our messages by saying self.messages equal to documents.compactMap snapshot, and return back an app message. We'll say do catch, and now we'll create our app message. We'll say var message equal to snapshot.data as app message.self. We need to make sure that our app message is optional, of course. Message.id equal to snapshot.documentID, and then we'll return our message. If this fails, we're just going to return nil. We'll make sure I mark this with a try and build and run. If I open up this chat, I can see that it doesn't actually show me the picker view because I've already set to here. But let's try and see what happens when we send a message. I noticed I actually wasn't getting any messages when I jumped back into this, and I was able to head over to Firebase and see that I'm actually storing it under message, not messages. And when we're retrieving from messages. So little things like that do make a difference. So if I go back to store message, make sure that this is meant to be messages. Let me build and run now and try that again. So let's go to new chat and I'll send a message. Hey, hi, hello. And now if I go back to our Firestore object, I can see that there is now the messages sub-collection. If I jump back, I can leave the chat. When I come back into the chat, now I can see all of the messages coming back the way they were supposed to. If I send another message, I can actually just continue back from where I left off. And those chats are now saved. I can create a new one and say I want it to be GPT-4. Try this out. And now GPT-4 is actually the model being used, and it's also saved there and not letting me use it anymore. There is only one last thing left for us to add, and that's the ability to delete our chats. So in our chat list view model, let's go to the delete chat function that we created much earlier in this tutorial. And here we're going to grab the chat ID. So guard let ID equal to chat.id, else we'll return. We'll say db.collection chats.document with this ID, and then we can just say delete. And you'll notice once this is deleted, it'll actually remove from our chat list view. So let's build and run that. I'll go ahead and delete this chat right here. Chat's gone. And if I head over to Firebase, you'll also see that that chat has disappeared. I know this has been a complicated series, but we've managed to get to the end of it and build an entire application that lets you work with ChatGPT. I will be uploading a new video that will go through how to add function calling to this same application. So make sure that you're subscribed to the channel and have the notification bell turned on so you can be notified once I publish that video. It's going to be an exciting one where we can then interact with APIs within our chat view. I hope you enjoyed this video and the series as much as I enjoyed making it, and I will catch you in the next one. Peace!